Hi folks, Mr. Long here with the last video for this question set where we're really breaking apart the first fundamental theorem of calculus and looking at all the pieces and how they connect. The relationship between what is fundamentally area under the rate curve and relating that to changes in y value on the original curve. Okay, the best way to keep this in context is snowfall, snow melt. Okay, snowfall, snow melt. Snowfall has a positive rate, so therefore it's positive area. Snow melt has a negative rate because snow is decreased. The depth of snow is decreasing at a rate of say 3 centimeters an hour, and that makes for a negative area. Okay, so let's look at this one. So the question, what I want to do is I want to fill in everything I can in this box. I want to fill in anything that's missing on the graphs. There's lots of different things. So what information do I have on this graph, the big graph of f at x? Well, I know that f at 0 equals 7. I know that big F at 10 is 2. So I can fill those things in. So big F at 0 is 7. Okay, that's that ordered pair there. And I know big F at 10 is 2. That's that ordered pair there. And so I can see that it changed by -5. Okay, the y value changed by -5. So if I go from 0 all the way up to 10, I know that that equals -5 because the y value on the original changed by -5. Right? I went from 7 all the way down to 2. So that changed by -5. Then that means the area under the rate curve from 0 to 10 is also -5. Okay, let's see what we can do with this graph. So it says here, and let's see, I've got A1 and A2. So what do I know about A1 and A2 based on what you just learned? Well, the area from 0 to 10 is -5. So then that means that A1 plus A2 equals A total. And by the way, what is this really? This is the area from 0 to 6 f at x dx plus the area plus the integral from 6 to 10 of f at x dx has to equal the total area, which is the area from 0 to 10 f at x dx. And we know already, we know what this is. We know the total area. We got that because the change was 7 down to 10. So that change is -5. So I know that's -5. And I know that A2 is 20, right? And what do I add to 20 to get -5? Well, pretty sure it's -25, right? 20 plus -25 is -5. So let's analyze this in terms of snow now. Okay, analyze this in terms of snow. So what's happening from 0 hours to 6 hours? The snow is melting. And then what does the snow do? Starts to accumulate again. Okay, so again, what you should do every time you're looking at these rate graphs, you should imagine what the original looks like. Okay, because we're always relating in calculus, whether it's what's called integral calculus, which is about areas fundamentally, and then the differential, which is about slopes. And people that learn those as separate things have that they don't access higher order stuff once you get to university. There is as you can see, I'm teaching it with the relationship between rate or slope and area. Okay, I want you to learn it together so you see relationships, right? It's like someone that taught only adding and then didn't relate it to subtraction. Okay, saw them as two separate things altogether. And that's definitely a mistake, okay? And this is the whole AP philosophy too, by the way. This isn't my philosophy. This is the AP philosophy, which I found to be a really, really good philosophy. Makes it harder, I think, initially, but boy, oh boy, once you get the ideas, you become a very, very, very strong calculus student. Okay, so again, I'll go over this. Negative rate means the snow is decreasing. Positive rate means the snow is getting deeper. What does that mean about x equals 6? What will it be? So the snow was melting until it got to 6 hours, and then it started to get deeper. So what does x equals 6 have on the original graph? It has to have a minimum. It has to have a minimum. Now the question is, we could even potentially figure out what that minimum is, right? And here's the thing, and this might be, again, it couldn't be snow melt because you can have negative snow. But just the same, I think we'll have a pretty good idea. So there must be a minimum at x equals 6. We know that. Now, what is that minimum? What will that minimum be? Well, I know that A1 is negative 25. So that means if I started at 7, I had to drop by 25. 7, and then I had to go down by 25 to get to there. So it would go all the way to 7 minus 25 is negative 18. So I'd be all the way down here at negative 18. Okay, so it would drop like so. And then we don't know the shape of the curve yet. But then it would have to, the A2, the positive area is 20. So then it had to go up by 20. And is that right? If I go from negative 18 up to 2, did I go up by 20? I sure did. I had to takes 18 to get to 0 and then another 2. Okay, so you can see, look at that. That's amazing, right? So you can take that graph there, that rate graph, and from that rate graph you can figure out, generally speaking, what the shape of the original function is. By the way, if that's a straight line, if you have a rate line that's a straight line, you have an accumulation, or original function rather, that is a parabola. And you'll see that very clearly later on. Okay, folks? So that's all. That's everything you can do in that question. Again, please stop now and go back and go to your blank copy of this lesson and do number 11, okay, based on everything that we just learned. Okay, and just look back at the notes only if you have to. Okay? Good luck. And now that's the last video in this series, so now you can go back and just start doing them. Okay? Start doing the questions, all of them. Okay, good luck.